Hello, this is just a quick overview of how to create your own app for the My TTGO Watch application. So I've managed to get this set up. I just ordered the TTGO Watch 2020 and had it delivered a couple of days ago. I've managed to get the latest version of the software installed, no problem. There is actually an over-the-air update as well once you kind of install things, so that's pretty good. If you don't want to make any modifications, you don't really need to get involved with IDEs and things like that. But part of the reason why I wanted to buy this watch was so that I could start making my own applications. And so when you load the application on the watch, you'll see there is a weather app and there is also an example app. The example app actually doesn't do anything. So in the background of the example app, you'll actually see it says My App, and then on the setup screen, you'll see there's a toggle. And the toggle is doesn't really have any functionality. It's just to kind of give you an idea of how to get moving with it. So you can see it's using this open source graphics library to create these components. It's quite easy to kind of get used to and get started with. So on the main file, you can see there are references to the weather app and the example app. Now what I wanted to do was try and actually build an alarm. It partly worked. I'll talk you through that in a second. So the reason why I have this is I've created a folder within the source app directory called alarm, and it's a duplicate of the example app folder. The only difference is I've gone through and I've changed all the references to example app to alarm, and similarly all the names within the text of where it says my app or something, I've changed that to say alarm. It's a very, very basic change, but it allowed me to start creating my own app. Now, as soon as you include that file and then configure it via the via the setup method, it will display on the phone. So if you navigate to the app section after having done this, you'll see there are three apps. There'll be the weather, there'll be the example app, and then there'll be your new app that you create. So you can test that more or less straight away. You'll see that I'm actually referencing the TTGO Watch class here. You don't necessarily need to do that. If you need to access that, you can actually just call this line of code within your source. But when I started building this, I didn't know that. So that's a change that I could make to make this a little bit more simple. So if we step into my class, there are three main files. You've got alarm, alarm main, and alarm setup. So setup is specific to the actual config screen. So if you press the little cog in the bottom corner, it gives you the option to see all this stuff. And at the moment, this is exactly the same as the example app. So it has that same toggle. I've changed the name, but this doesn't do anything. If this was to work properly, I would be able to put a time or even potentially a date picker in here, even maybe make it so that you could select multiple alarms and manage them in this screen. But I'm not going to do that at this point because the alarm itself doesn't function the way that I need it to. Which I'll talk to you about in a moment. So you can see as you go into the alarm class, it will call alarm setup, and that then goes through and calls the main setup and then the setup, which just initializes everything and makes it ready to render on the screen. So most of the changes that I've made are actually inside alarm main and alarm main setup. So again, this reference isn't normally there. You don't need that, but I'm actually using it still in the setup. So what I wanted to do was, there's an example script which you can take a look at in the TTGO T-Watch library directory. There's a load of examples in here. One of them is around creating an alarm, but without the additional TTGO Watch framework that we're trying to get this working in. So what it does is it creates an interrupt on the RTC pin, and if there is an interrupt, then it sets this flag to true effectively. Then you disable the alarm, set the time randomly, and then set the alarm for a minute's time, then enable the alarm. And of course on this simple script, it's just going to run through this loop over and over again until the flag is set to true, or 1 in this case, at which point it's going to turn it off, it's going to detach the interrupt, reset the alarm, and then 3 times it's going to go through and flash the screen, I guess, between red and black, with the text as between red and white or something like that. But it's going to flash the text around a few times just to say the alarm's going off. And this is really just a test of the real-time clock. Another script that I've used here is this one, where you can understand basically it will trigger the motor, which is the vibration motor, to vibrate if something happens until you touch the screen. That's a slightly different way of reading it. This I didn't find worked, but if you actually go into the touchpad, you've got this TTGO touched check, and if it is touched, then you can do something else. So I kind of combined the two. So within this, you've got the option, if I jump back out again, go back into my alarm, you can see that I'm starting that motor interface, I'm attaching the interrupt, I'm also putting some logging in there just to help out. And then I'm still setting the date time to a random date, even though it's set within the main framework. And that's because without that, this didn't seem to trigger under any circumstances. So that's something to bear in mind. I could probably work this through. It's probably a race condition that we're setting this before the clock has the date set and the time set. So it's messing things up. But yeah, we can research that at a later date. So it'll go through and enable the alarm, and then this is just around kind of rendering the default stuff for the example app to the screen. Then the alarm task. So what happens is at the bottom here is it'll create a new task to call this method every second. And what I'm doing is just checking that flag on the interrupt in the same way that it did in the example script. Now if it's high, then it's going to sound the alarm. It's going to detach that interrupt. It's going to get an instance of that watch, and then it will do the. So in my case, it's a white screen with black text that just says alarm, and it'll keep doing that over and over again. It'll keep looping through this until you touch the screen. So if you're not touching the screen, the motor is just going to keep vibrating, and it's just going to keep doing it. And then once you touch the screen, it's going to just disable that flag and allow you to kind of use the phone or the watch as normal. So this last piece is around trying to set the alarm for 7 a.m. It didn't work quite as well as I expected it to. So what does it do? At the moment, if you have your screen active the entire time, it will sound an alarm after a minute, it appears. So this is fine, this all works really well. If you could manage to keep your phone, your watch awake until 7 a.m., it would probably do this as well, I would imagine. But I'm finding because we have power management running now, which wasn't in the example script, what will happen is it's actually going to go through and just put the ESP to sleep, and then this never gets triggered, the interrupt never gets triggered while it's in sleep mode. So sometimes when you wake it up, the alarm might go off after the fact, but it's not triggering to wake it. So that's something that I need to solve. I might park this for now. It might just be that it's not worth kind of implementing this. But if you know a way of getting this to work, then feel free to add it to the comments. It'd be really interesting to see whether we could actually build this up. So I'm going to make this source available. So if anybody wants to take this and fork it and do whatever they want to with it, then feel free. I'm not going to work on this for too much longer until we can kind of solve that issue. So you can see in the weather app, there's actually some options here to kind of fetch from an HTTP server and a call out. So this is an interesting option because it means we can potentially make call outs to, if we were looking to get the latest news or whatever, we could import that to the watch. And that's potentially one of the things I'll try next. So hopefully this is useful to someone, and feel free to leave a comment if you do use it, and if you know the issue or how to solve this issue around the sleep for the interrupt, then feel free to let me know. Thanks.